Hey. Okay. I think it's it. I don't know.
Is it?
I'm always like, I think it started. I don't know. Maybe.
We'll find out.
We're live.
Yeah. We'll find out. But
Going live in three.
yeah, I
Let's
usually
see if
give
I
it like
can.
a minute or two to I don't know,
Yeah, it's the
make sure it
starting
goes.
screen, right?
Yeah, the starting screen. It's like we're here.
Oh, yep, we're in.
Okay, good. So I guess I'll just start it because obviously we have a lot to talk about, and whoever joins joins. Whoever is here, you know, we'll see who comes in. But we're here to talk about what happened last week. And I'm sure
What did happen
we all
last
just
week?
kind of laugh about it because it was a mess. So we have a special guest tonight, Carina. Carina, how do you say her name?
Karina.
Carina. I always feel like I mess it up, so I need to ask. But she's a space
As
weather
long as you don't call me
forecaster.
Korea, we're good.
Yeah, Carina.
What?
So Carina
Not sure how you get that.
is an actual space weather forecaster. So she's here to basically go over on how difficult this was last week to nail down, and we'll just kind of talk about the uncertainties and what actually transpired. Even though we don't really, I don't think we really will know exactly what ended up hitting at all, but it's kind of interesting. So anyway, that's the gist of the stream today. So I want to thank her for coming on because this is super cool. I always get excited when she comes on. So, so I'll
Anytime.
yes. So thank you, and I'll let you guys take over because I know Tanya's gonna drive the slideshow since I always mess it up.
All right. Well, let's see if I have typos this week. It's
I
always a
didn't see any.
challenge. Oh, okay. So, yeah,
Not
so
to say there's
CMS.
not, but I didn't see any.
All right. So CMS is actually intentional because that's exactly what it turned out
Mm,
to be. But just to orient everybody as far as where we at, we have a very different on disk situation right now. We do have a few active regions that are simple and really not a huge flare players. Although again, that can change at any time, but right now there is really nothing super exciting. But there is a coronal hole, or more like coronal holes. There might be a continuity between those islands of coronal
mm,
hole, but that's kind of hard to see, and that's why they're mapped separately. But we are very excited about this part because it's transequatorial, so
yeah.
it will hit. It's not gonna miss us, unlike the CMEs. And it's definitely coming, but that's going to be a bit later this week. It still probably is good. Well, probably a couple days away from crossing the central meridian. And then 3, 4 days afterwards, we'll see what it brings. But it's coming, so more Aurora. Yay.
Yay.
Um, yeah, so that was a very interesting week as we suspected the active regions decided to do something and tossed us a few CMEs, more like not us directly, but in all possible directions, including Earth. We had a few arrivals of variable strength and variable geomagnetic impact, and right now we're in the fast solar wind from the coronal hole. This part of the same big structure that is snaky coronal hole, let's call it a snake. But that's where we at. It's been a busy week for
Yes,
sure.
to say the least.
It has been a super busy week for forecasters and analysts because those are just a few of Earth-directed CMEs that I pulled from the M2M database. And we remember the December 6th CMEs, the one that was really slow and the one that looked fast. And then December 8th gave us a couple more interesting CMEs to talk about. But even that X1 CME already was looking more kind of going sideways, not Earth directed because, well, it was Earth directed, but more of well, not exactly aimed at us, more of a glancing blow. So that was one big mess, and that created a huge mess in interplanetary space with all of the CMEs moving and potentially interacting with each other, which is exactly what happened. So this is just a picture. This is a review of what happened over the course of the week. On December 7th, we were still probably at the tail end of a structure when something arrived. We don't know what it was exactly, but it was super slow. Density went down, speed was going down. Wasn't that impressive, but if you look at the entire week, BZ has been very close to 10 or above it, pretty much up until what, today?
Mm-hmm.
Well, yeah. So it's been rough time for our magnetosphere. Some of it came with favorable BZ for Aurora. This is one structure that arrived. There's a little bit of a bump. This is another structure that arrived. There's a little bit of a bump. That's another one. This is a big one, and it could be more of the. It could be potentially connected to 2.4 flare CME, but this one, your guess is as good as mine, and I don't think it's really going to be that easy to attribute anything in that mess to anything specific, except this is fast solar wind. I know it.
Yeah, we know that.
Yeah, that's the only certainty I'm willing to take on this one. Everything else is up for grabs. So that brings us to the discussion of really where we at with forecasting and CME analysis. And I wish that was a lot simpler than it really is. But this is where we have Carina to talk about it.
Like, yes.
Yeah. So
actually, I can stop sharing if you want to share the slide deck and drive.
No, that's okay.
Right.
You're good. I was just gonna say that. So first off, this is not an official view from anyone on my team or anything. This is my personal take. But basically, so I provided 2 screenshots, this one and the next page, but basically showing you how messy it looks for an analyst to try and get an idea of how to measure this mess. So if you look from Stereo Head's perspective on the right, it looks like, oh yeah, it would fit in that if I adjust that little loop, that little lasso. I could get it to fit very nicely there. That's not the case in the center there, though, right? You're not gonna get the perfect match. And that's where the problem was with this, because basically what you're seeing towards the north is what I think is part of most of the bulk. So I think most of the bulk from this is the X1 Cloudflare related CME, the X1.1. I think a good chunk of the bulk may have gone north and not necessarily towards us, or only part of it went towards us. And then you've got a mess of all of these other features with it as well that were all coming out around the same time. And so you could only do basically what this would do, and it's going to assume from the Soho perspective, which is in the middle, that it's coming right at you in a perfect circle, which is not the case at all. As you can see, it's more like a triangle, and we can't lasso with a triangle. So it's going to assume that it's a beautiful, perfect, symmetrical circle. It looks really nice from Stereo's perspective, but it's not reality. And then to make it even more difficult, if you go to the next page, when we look at what the CME looks like when you kind of adjust, you can adjust the imagery a little bit. So I've switched to Soho C3 in the middle here, and the Stereo Head I've played with the saturation, so you can kind of see where that bulk is a little more. Originally, it looks much larger, and here it's much more narrow, and it looks like a chunk of it is mostly to the north and not so much in that ecliptic plane. And so I think what possibly happened is that it was north of us a little bit, and then possibly I think it might have missed us mostly. I think we got a glance from it, not direct or anything. I think it was too messy of a CME. There's too much going on. And that's my opinion with this, at least. And then when it came to the simulations, they were a mess too. So the simulations took what we already simplified down and simplified it even more, which then gives you a very inaccurate forecast. So it's like, I have a piece of bread and you somehow end up with a crumb. It's not that same piece of bread at the end. So
It's
I
CME
just-
telephone.
Yeah.
For those that
it
remember that
was-
game.
Yeah, basically. It was just not, the CME was doomed from the start. I remember I was working on the ensemble for it, and I had to measure it multiple times for the ensemble, and I was like, this is not good.
Yeah, like this isn't gonna work.
This is not realistic. I can't get a good fit. I can't even get what I want to fit together. Like, no matter how you play with the latitude, longitude, and everything, it just wasn't fitting how you expected it to fit. And so it was like you either had to favor you were seeing in stereo head, or you had to favor what you were seeing in Soho. And usually in this case, because you're getting a better plane of sky view from stereo, you would lean towards what you see in stereo. But of course, that's going to fail in what you're seeing in Soho. So it was just a mess. It was a glorious mess. And then in the simulations, so with the simulations, the difficult thing was that you had a slow CME ahead of this, and then you had this fast CME coming behind it. But the simulations themselves, they don't look at the start time of the CME from the coronagraph's perspective. They want to know, what time will I see them at 21.5 solar radii, so that I can put that in the background solar wind from that point in space, which means the times were switched. And so the CME that we saw first, that was slower, and the CME that came after the CME that was faster, instead of them coming out as you expected and what you visually saw, they came out backwards. And so the fast CME went first and the slow CME came behind it in simulations when you simulated them together. So it wasn't realistic. And so that was also doomed. But these are limitations we have. So like there's only so much you can do. And then the last limitation I think that we noticed, or like at least I noticed, was the CME itself wasn't very dense. There was like no mass to the CME. It was so faint. It was like from stereo ahead, it looks more dense, but in Soho, it did not have hardly any dense material that you could clearly see. Most of it was to the north. And so what we were measuring wasn't all that dense, and we can't change that in the simulations. And so it's going to over forecast those KPs. And so it was a gross over forecast of the KPs. So, and unfortunately I personally will not change what the model says, because I can't tell you how wrong it is or how right it is. I can just tell you, yeah, that's not realistic, but I can't tell you what I think the realistic KP should be. So I won't change it.
Yeah. That's a good description of all that.
It is a good description, and the physics of it is interesting. That there is a lot. I think the time between the launches was about an hour.
Yeah, they were really close to each other.
And there is a lot that can happen in an hour, even with one slow and then one fast CME. There's a lot of interaction that can happen between the launch place and by the time you sort of putting them into the model. And there is just no way to track as far as what exactly happens to one CME and another CME.
Yeah.
So,
do you think we'll ever get to a point where you could actually not make them circles in the model, or the like where you can actually put bends
like
on
the
them?
measuring tool, the Enlil model?
Well, ideally both, but
yeah,
it seems like in the measuring tool that would be more doable, maybe.
Yeah, I know of some folks who are trying to come up with different measuring tools, because the other difficulty is that if part of the CME is traveling faster than another part of it, you can't capture that either.
That is
true. Basically you pick a latitude and a longitude and you start matching that, and you can't change that throughout the measurement. So if the CME deflects within the field of view, like north or south, if it drifts north or south, you can't change that. And so that's another limitation with this measuring tool. Now, don't get me wrong, this measuring tool is a blessing because we have something.
Yeah, right.
But it feels very much like I'm using a circle and I'm just drawing with a pencil and I'm like,
Yeah.
okay, I'm just going to keep moving the circle, and that's not helpful when the CME is like, I'm like this, and so it's not realistic. And I know there are efforts to try and come up with things, but the hard thing is trying, I think, and this is something I've personally wanted to fix, is getting that in the hands of forecasters to actually play with and find out, okay, would this be better? Would this be useful? And then also knowing, if I do it this way, will me putting it in the simulations end up giving me a better result or a worse result? Like, will it actually help or not? Because at that point, you still need to get your normal parameters. You need to get a t at 21.5. You need to get a latitude, a longitude, a velocity. And so it's going to have to average out those different latitudes you play with, the different longitudes you play with. So eventually you're going to end up still getting to a simplified thing, so that you can put in single parameters in a simulation. That's the unfortunate part. And then the simulations all have their limitations with how, like, it's all simplified physics. And I know a lot of scientists are annoyed with that.
Right.
And they want it fixed. But the realisticness of in a forecasting setting is that a lot of times they just need it fast.
Yeah.
They just need the best they can do in a reasonable amount of time in order to get something out to say, hey, we know something's coming. This is your preparation, especially with the faster CMEs. Like, you need something that you can do really quick and get out and then get an answer and set out warnings. So there's a balance. It's a very difficult balance. I think a lot of folks are trying to figure out machine learning options and AI options. I don't think you'll ever be able to get away from a human in the loop aspect, though. There's no way you can, because anyone who, in my personal opinion, anyone who tells me, oh yeah, we're going to have it auto detect CMEs, I'm like, how are you going to tell it where the source is? How are you going to explain how that source acts? How are you going to differentiate when there's multiple flares happening at the same time on the sun, which one caused that eruption? And what if it's farsighted? We have no eyes. How are you going to differentiate that? How are you going to know? You're not going to be able to do that, because even the human in the loop has a hard time doing that. You can't train it off of something that doesn't exist yet. So
makes sense.
Yeah. I mean, sun was particularly nasty on this day because there was something going on the far side too. So sounds like the estimate was really the best that it could have been done. And it was sheer luck that this eruption was not greater, because I think that would have messed up measurements even further.
Yes, absolutely.
Yeah. It's just,
and that's
making me think of the May storms.
Yeah. And it's like, it's our luck that we actually have stereo looking at the sun from the side, as opposed to Soho, which is looking straight at it.
Right.
We see what's happening on the far side right now, but we're not going to be lucky like that all the time.
No. And like right now, we're lucky to have what we do have. I'm excited for when Vigil launches, so we can get that viewpoint from Vigil. I do think, though, that we need like, I just want someone, like, whoever's out there, if you're listening to this and you can make my dreams come true, can you send out an army of like CubeSats that just circle the sun and just have imagers on them, like, and maybe some in situ solar wind monitors on them, and just let them all go in circles? I want the minions around the sun all the time. Like, that's all I want, and I just need that data so bad.
Yes.
We need something that's also polar orbiting, not just around the sun and the ecliptic. We need something that's like looking at the
Solar
poles.
Orbiter's been doing a good job.
Yeah.
We've been getting a lot of good data with Solar Orbiter, but it's definitely, it's not continuously over by the poles. It's
always
really far away from the sun, and then really close to the sun, and then really far away, just like Parker Solar Probe when it, which it's in its close perihelion pass right now. So that also makes analyzing CMEs tricky, because the coronagraphs go into campaign mode to support Parker Solar Probe's passes, which means less imagery.
Yeah.
And so you get one frame of stereo head an hour.
Yeah,
So,
that's a slight problem.
well, it's a scientific mission to begin
It
with.
is, it
So,
It is. It
Yeah.
is. Right, which is why on the left we now have Go C-Core, right? So C-Core
Yeah.
is the first operational chronograph.
Mhm.
And so that has been useful, especially in campaign periods. You've been able to use Go C-Core. So I will say thank God for that. Because otherwise we'd be flying blind a lot of the time and just go, oh, oops, sorry, I can't see it. I know an eruption
Wow.
happened.
Yeah, waiting for Solar One to become operational.
Mm-hmm.
I think April of 26. So getting
Yeah,
there.
I think I heard it was supposed to be early next year, so can't wait.
Yep.
I just want more data. That's all I want.
Yeah.
More data. And like right now where Mars is on the far side, so it's headed into solar conjunction.
Oh,
So
okay.
that's exciting.
Yeah, I learned a little bit about some of the Mars stuff at Space Weather Workshop or Week or whatever, and how, the challenges of that, like it being on the far side. It's like, how do you get communications from them? You can't see
Exactly.
it.
Yeah.
So, yeah,
Yeah.
a lot of big hurdles.
Yeah, I mean, I think there's a lot of fears with that because with stereo behind, when it literally went behind the sun,
Yeah.
we lost contact.
Yep.
So, but
Yeah, I heard that was that was a kind of a funny conversation too, because they were talking about, like this, where can we put more things
Yeah.
for data? And somebody
Yeah.
mentioned was it L3 over there behind the sun?
Yep.
like on the other side.
And then
yeah.
the one lady immediately, she got up, she's like, but stereo B, because like because that was when all things
But
went
see,
to
my
bad.
thought is if you get a set of 3 spacecrafts that all talk to each other with a fourth at L1, you use L4 and L5 and L3, and they can communicate to each other that way, so they triangulate around the sun.
Yeah.
Can we do that?
Yeah, like, hey.
Can we get stereo C? Can we? I want stereo A, B, and C now, and then have them permanently stationed at L4, L5, and L3, so
Yes.
that I have a triangular communication, and then we can have stereo D at home.
I like it.
Yeah.
Well,
Anyway,
hopefully that's coming. But
it would help this. It would help this situation.
It would help so many things.
Yeah.
So many.
all right. So this is what's happening now.
Yes.
Up until now. That was let's see, arrival. That was yesterday. So as usual, Coronel Hole decided to show up in a good company, and there probably was something there. Probably a couple of structures that got compressed and produced very nice shows for Europe and a little bit for United States, but by the time it rolled into our night, it was all BZ North, and that pretty much shut down the show, despite having very nice total magnetic field strength, so that didn't help any. And that structure probably just dissipated, so that could have been potentially a glancing blow that got mingled up and compressed into CIR because this is a recurring kernel hole, and speed went up. Density is now dropping and has dropped substantially. Temperature, I mean, this is probably one of the compression regions over here because temperature went up too.
Mhm.
So we're not looking at a whole lot of exciting stuff for Aurora, unfortunately, at this point, and which is actually kind of good, at least for Upper Midwest, because we are dealing with absolutely insane cold. So if you are watching this and planning to chase, do so virtually and pick a station or a webcam that's very close to the pole, because this solar wind's not going to produce anything exciting, at least the way it is right now. Definitely a few substorms, but nothing too thrilling, nothing worth losing your fingers and toes to frostbite.
That's for sure.
So this is a returning kernel hole, but it managed to expand on its last rotation. So kernel holes can be somewhat unpredictable as far as what they do, particularly when it's surge. Some of them shrink because they're starting to get sort of crowded out by new active regions, and some of them can expand. So this hole decided to expand. And this was its last pass, so not particularly exciting. There was a little bit of substorming going on with the periods of favorable VZ, but this is now. So that was probably a structure. So that's earlier structure. That's the CME that came through. And this is a different structure. So a few periods of favorable VZ, and sure enough, they're producing nice substorms. Very nice period over here. Lucky Europe. I want to be there for that because it was absolutely spectacular. They saw, I think they got Steve Ansar arc, Proton Aurora.
There was some decent stuff on the Ely, Minnesota cam from that. Like
It
early
wasn't.
on. It was like 6:30 in the evening.
Yeah, a little bit, but it was
Yeah.
we still haven't fully rotated under Auroral Oval, so it was still fairly low on the horizon. That previous, I think, couple of nights was a little different. So that was on the 12th, and the 11th was really fun night.
Mhm.
But most of it, I mean, we're in fast solar wind, density is way down, BT is down, so that's not going to do anything too impressive. Doesn't mean it's not going to do anything at all, but it's just going to be you're chasing substorms. There's not going to be anything sustained. Well, big take home. Mary Beth, you want to cover it?
Oh, me? Yeah.
Sure.
Well, I mean, we kind of cover. Well, you know, this forecasting is difficult, especially when you come to these compound events where you get multiple flares, multiple CMEs, and certain flares that don't produce the biggest of CMEs, and sometimes the littler ones end up being more geoeffective than the larger flares and flare CMEs, I should say. And then, as we covered, limited observations make forecasting really hard. Because, like, I will be honest, like, when that first couple images came through with stereo A, it did look pretty promising.
Mm-hmm.
It really did. So I could see why, there was some caution, err on the side of caution at that, because it did look pretty good. But ended up not being the case until the littler one came through, and that was pretty decent. But what did we get? I think we got, it was just shy of, it was like G2 at least.
Yep.
So, but a little shy of the G3 predictions. And the stakeholders are the ones that usually all the stuff is put out for, so you always get those kind of over predictions for that reason. So always treat the forecast as a possibility, not a certainty. As tempting as it is, to jump on the hype train, it's I get it. The FOMO is a thing, I do, but when you have these types of weird things, you just be a little leery of it. So that's what I have to say. But I think so I think Christian, you got that video? You should show that video to put these CMEs in motion. You can see just how crazy silly this was.
At least for the Glasgow point of view, yeah, it's kind of a nightmare. Wait. Oh, I'm unmuted. Okay, good.
Yeah.
It's a kind of a nightmare looking through the Glasgow point of view. There's only really one hardcore identifiable CME, and in that case, it was the M8, which was honestly not as impressive as I thought it was going to be.
It was probably the most disappointing one out of all of them.
Yeah. So let's jump in here. So this is Glasgow C2, C3 imagery with running differentials just to see. This is literally from the 6th to, I think I put the 12th. So it's just kind of a running total of everything that's been going on. It's kind of fast to get through the frames, and there was a small frame gap, but literally that was it. That CME there was pretty much the only real identifiable one that you could see. Now there's a couple different ones. We had the far side one or the upper side. There's several different ones getting shot up from the sides. And then on the 8th, we had the one that went to the side, the west, the X1 there. But this is really when the whole mess started, and I probably spent at least 10 or 15 minutes trying to look at this imagery myself, like maybe a halo outline or a sign of something that was coming. No, honestly, the only thing I see is the 9th eventually. Well, if it's going to squeeze in on itself, I should probably not track. That would help. eventually we get some kind of almost halo-y outline from here, which I'm not actually sure which flares those were, but after the 9th, and I'm not actually sure those were even relevant to us at this point. But the ones that we had that hit Earth, at least, were not anywhere near cut and dry. They were very faint and kind of blended in with the background for the most part. So
Yeah, that's why I like this is great to see because I'm like I took like a couple looks at this. I'm like I have no idea. I'm like,
So like
Yeah.
I'll let it just play all the way through to kind of get the idea here. But and actually, I did notice it was very slightly easier if we go ahead and just keep the differential imagery off. I was able to see a little bit better the outlines that came out.
yeah,
Which again, there's our M8 flare, and then a whole lot of just puffs out to the side, and then there was the actually you had there X1 and then the M8. Which again, if you can identify them in any way, by all means, let me know how that works. I can't tell. It does look like there's a faint outline. I want to say, and see, it's even harder to really tell, but there is a faint outline shortly. I want to say the 9th, right after the 9th. That kind of gives me a glimpse, like all through here, that might have been something coming our way as well. But so that's the Lasgo frame of view, which was not as helpful. Stereo A I've never been able to pull up through JHelio Viewer, unfortunately, so nothing cool there. But I did at least get a decent video going of the photogenic flares. So the M8 that was on here. Let's take running differentials off.
I mean they were pretty. Well, some
Yeah, they were absolutely gorgeous.
It's not their fault that the CME essentially blended in with a slow solar wind.
just
I mean, the sun doesn't give a crap what it's doing. It's just doing what it's doing.
Yep.
And then let's go up to 45 here. This is kind of taxing in my laptop too when I'm running 3 channels all in different wavelengths, trying to capture really the elegance of any sort of flares. But we've got the first initial flare that happened here and the eruption that shot off to the northeast. And then an hour and a half later is where we get the big one. I only have the frame for that, but yeah. And then, of course, we get some nice post-eruption arcades. Those are my favorite.
Aww.
I always have to include 171 on this for, those nice little loops. That magnetic field reconfiguration. It's just so pretty. But yeah, it's at least some photogenic, but no, this is a total crap show. CMEs indeed. And that's what I've got. Unless we want to see any of their imagery.
I think that's it.
Yep.
But that's now the other thing that was mixed in here, and maybe Carina has an input on that weird filament eruption that was kind of like twisted on itself.
That's the M2.4
That's the M2
eruption.
Yeah, because like that one was kind of difficult, because of that like weird twisting effect that it was doing.
A lot of it looked like it was reabsorbed too at that point.
Yeah.
I was gonna say, I'm gonna be honest, I didn't get to measure that one. So.
Oh, you didn't? Okay.
So, when you work rotating shifts, you only know half the stuff that's happening.
Okay, I got you.
Yeah, that's especially when it decides to all happen at once.
Yeah, I know that one was really bizarre, and
yeah,
I know Tamitha's remarked on it too, and because that was the one she was mostly watching, because it was the denser of the all these things. But
I think that was the one that actually came through.
Yeah, that one with the bigger impact.
I think it was modeled to be more head-on too.
Yeah.
Versus the other ones.
Mm-hmm.
So
yep.
I think that one was...
I actually have it in Solar Demon.
Yeah.
I've got it loading up too, but it'll take quite a few minutes. So
it's
by all means, feel free.
It was a weird looking eruption. Like I've never seen one like quite twisted, like basically twisted around itself. It was bizarre. And if he gets that image to come out, you'll see it.
Let me share it. That's not doing it. Hold on for a sec.
Oh crap!
Like
my memory's full.
loading.
Ugh.
Oh, that's not good.
All right, let's kind of get rid of some things here. Yeah, JHelio Viewer plus Zoom equals need new laptop.
Fair enough. Okay, there we go. I got it. So this was
Yeah, look at just how it
that
just like
flare.
even came out like it was like a, it reminded me of, when it's really cold like it is right now, and you like throw the water in the air, and it does that like fan. That's what it looked like to me. It was like whoop.
Ooh, that's cool. I
Yeah.
like
Twisty.
that.
Twisty. Very twisty.
Yeah, it's so twisty, and then it like comes back on itself. It's crazy.
Interesting.
Mm-hmm.
This is back on the 7th and 8th.
Yeah.
I'm gonna pull it up in Ice Watch.
Might as well.
But this one actually arrived, and it was low inclination, so it produced nice southern field and then switched to north.
Yeah. Yeah, that was the one that gave us the better stuff. I got them.
Yes,
Yeah.
that was the G2.
Yeah, I've gotten all the dates. I haven't known really what day it's been all week, so yeah.
Well, all this happened within a 3-day period.
I had clouds.
Yeah, that's the other problem too. Is I had clouds too, so I didn't really,
Are there not clouds in winter? Like,
yes,
is blue
then
sky a
it's
thing?
minus 30 degrees Fahrenheit. So it's
fine.
either
That
clouds
the
or.
clouds. You can always bundle up.
Yeah, that's true.
I like cold though, so I don't know if I count.
Can't chase clouds away.
No. As much as I want to try, you can't do it.
And you do try.
I do
Yep.
try.
All right.
I have the well, I'll have it here very shortly. The filament launch from that M2.
Yeah, is
I've got frames that are loading up
that
now
was
at
like
least.
probably the coolest looking thing. Bizarro land, but cool. And again, it makes everything difficult. You're trying to forecast it. It's like, where is that going? I don't know. Some of it's going up here, some of it's going down there, and I think when I was watching one of Tamitha's feed, she actually, because she does that 3D animation now, and she actually made it a lot wider, because, like you were saying, you can't put bends in there, so she tried to like make it wider to encompass, the northern deflection and the southern, like, the rotation. So it's kind of interesting. Very interesting. It's like all's quiet, trying to wait for computers.
Yeah. I'm writing a check this thing can't cache, that's for sure.
Well, I mean, to Carina's point, like the reason why they gotta simplify the physics so much is because of the computing
Computational
power.
effort involved in it. Yeah.
Yeah, exactly.
So
Well, not to mention, to be quite fair, if the actual equations of MHD trying to solve them exactly, I don't think is an actual thing. I think they all have to take approximations to model.
Well, all models are wrong, some are useful.
It's been a minute since I've heard that phrase.
I mean, like
Glad
for
we
the
have that again.
most part, it seems like it does a fairly, like what we have right now, it does a fairly decent job with a lot of things.
Sometimes.
But considering the limitations, but you get like these types of events, and it's just like, no, none of this is gonna work right.
Yeah.
So you gotta make your best
almost.
judgment.
But then, unfortunately, we are dealing with an issue that every time a higher level
I know.
G-scale forecast is posted, it's going to end up all over social media. So people will get excited.
Yep.
And unfortunately, you could hear it in the news sometimes, and people will be told that, oh, yeah, it is predicted to arrive at this specific time. So we're
Which
going to
is
see
so
Aurora
wrong.
Yeah.
at this
it's like,
specific time, and all you have to do is find the dark sky and look north.
it's like, no.
Those
They
are
can't do
the
that with regular weather. They can't even with terrestrial weather. They can't even say it's going to rain at this exact time in this exact location.
So why would the Aurora
would we
be
be able
better?
to do it with even less data for space? It's not realistic.
It's not.
because it's exciting. Because Aurora, because
sure,
that's what
yeah, and
people
I
want to
think-
see.
I think what I'm most happy about is that just people are, getting to learn stuff.
Yeah, that's true.
That flare
You
is-
learn the best through
is
disappointment.
so cool.
if you're willing to learn, because another thing that's unfortunately very easy to see, well, the scientists don't know anything, which is not going to trust them.
Yeah.
Yeah, that's always a sad side effect sometimes.
Yes.
Which is why we try to, as much as we can, when we do these things, we always try to harp on the uncertainties about surrounding this, because it's a major thing. So, all right, we got some images.
Mm.
Oh,
good,
yeah,
'cause
isn't that
I'm-
cool?
Mine
look
might
at
take another
that.
hour.
Yeah.
Oh,
It's
this
like
is fun.
You get the bigger field of view and goes anyway.
Pretty.
Yeah, that's pretty
I
cool.
like that good twist. That's just stunning. It does. It has a really nice twist.
Yeah.
Which
Yeah.
is really cool.
And there's no way any model we have right now can actually account for this.
No.
Yeah.
Such a twist, and it's kind of going. It's going.
Right, and you can see that loop so well at the beginning. Like that loop
Yeah.
right there. That's so cool. I love a good filament eruption.
Right.
They are the most pleasing to watch.
They
You ever seen
really
one in
are.
an H alpha scope
Yeah.
while it's happening?
I have not.
Oh, it's a lot of fun.
I've seen an H alpha, like I've seen the prominences on the side, but
Oh,
I've
yeah,
never
yeah.
seen it erupt.
I got to look at a few. Well, I had one for a while too, but looked at a few on the Oshu tower, a main like astronomy tower we have up there. But it was the peak of solar cycle 24, so I got to watch I think an Image 4 happen at the same time with a filament launch.
Pretty cool.
It's what inspired me to get an actual telescope and spend. God, those were $1,600, I think, at that time. Those are not cheap telescopes.
No, they're not.
We're trying to
That's
see
why
it
it's always
into-
good to have friends that have them.
if
That's
you're
why I always like go
unfamiliar
outside and be like, "Hey, people, come and look at this. I'm going to be out with a scope at this time." Sidewalk astronomy.
Yeah.
And I just love it how it dissipates as it leaves the sun.
Yeah.
You sort of see like a sun cloud.
Yeah. There's so much going on. I'm just trying to get the images to load. They're slow.
Makes two of us.
Yeah.
I just got out of Helio
Right,
here
right.
entirely now.
Yeah, look at there you go. It's just it's so crazy looking.
Yeah.
Gee.
I was kind of curious to see if there was more of an EUV wave with it, but it's hard to get that to show me.
Yeah.
Is it going slow? Oh yeah. Oh, interesting. Yeah.
Yeah, so
There's,
that
yeah,
one
it's
was-
like must be magnetically connected through here along the side of this coronal hole, which makes me wonder if that's why it twists like that, is because the magnetic field lines around this coronal hole are warping it.
That's I could see that.
Coronal holes do weird things to eruptions.
Yeah, they do. We've been learning
really
that.
do.
Even when they're kind of
And
like
depending on the polarity of the coronal hole, it'll change what it does to the eruptions in between. And this guy's kind of sandwiched because I think there's some coronal hole over here at that time, and then you got the coronal hole over here, which would do some fun stuff.
Ooh, okay. I got it. Turns out restarting JHelio worked pretty well, but
Oh my god.
got some high resolution data if you want it.
Go for it. Huzzah! This
Yeah.
is just what we use daily. That's how I do my job. I don't have JHelio. I used it when I was an intern, but I don't have it on my computer.
Aw.
It's so useful for
I know.
everything.
It really is. I know.
Especially now that I learned how to combine the channels, which I can't believe I didn't know how to do earlier, but
Yeah, it makes them really
okay,
cool.
it was just playing pretty fast, and now it's not.
That's
Oh,
because
Probably
I
because
guess
you're sharing screen.
yeah, because you're sharing the screen now. It's that extra
Yeah, fair point.
that extra bandwidth. It can't handle it.
Oh,
Yeah,
there it
there
you
goes.
could try turning off
Look
your
at that.
camera. And see if that would help.
Ooh.
Oh,
That's
yeah.
That is so
nice.
pretty. And then it fans out.
Yeah.
Yeah.
And there's
I'm gonna
you
try
can
the
see that
turn
cloud
camera off
going.
method.
Wow. That is
It's
That is
so
fun.
pretty.
Yeah, I don't think that made a difference, but that's okay.
The attempt was worth it. Ugh, it's so pretty.
Yeah,
Yeah,
it's just-
it's just
I
got
don't
such
know.
a nice fan out and everything. Such a wave. It's riding
And then you
these
see it get
waves.
to go like all the way into the southern area over here too. Some of that.
that was a separate one.
No, I mean there was some of this as well that was pulled through the magnetic field lines over here through this area.
And
So,
if you look at that area, that was a very small
Yes.
eruption there too.
so
Yep.
that
Yep.
stuff right here.
Yep.
It's
Yeah,
pretty cool.
it's like
Which
solar
it's hard
cloud.
to tell for sure if that's just getting pulled into the stuff closer to the sun or if it's just your perspective playing tricks on you and it's just coming towards you, but it
Oh.
looks like it's
But it's
going
moving
somewhere
slightly
else.
this way.
Yeah,
So a smaller parallax.
yeah,
That makes sense.
yeah.
Why is the blue channel so bright on this?
Again, this is why AI will never replace the human in the loop part.
Yes.
No. I mean, there has to be someone around to be like, this looks and could be right.
Yeah.
I'm going to eventually have a full... Oh, there we go. Now we're starting to see some...
It's really cool. So anyway, I thought I'd bring that up because I just thought it was the coolest one out of the whole
Yep.
slew of things.
Everything. Yeah.
So that's it. So I don't know if you have, yeah. Steve's like it moved southeast a long way. It moved. It had a long twist, but
And again, either it, like she said, either moves that way
Or
or
it's coming
moving
at us.
at you. In
Yeah.
which
Actually,
case,
that would be
southwest
southwest.
Yeah.
Yeah.
because the coordinates are flipped or
Because the sun.
yeah because sun.
Yeah, because the sun is the stage and we are the audience.
Mm-hmm.
So it is
Stage
stage
left.
right and stage left,
Yeah.
but on the sun. So
It's just just more stuff to add to the confusion of all these things.
I mean, directions are arbitrary anyway. You can pick any direction to be your north. Just makes sense to pick some directions over others.
Yeah. I mean, that's why I have a hard time looking at but Solar Orbiter, because I can't.
Those are RTN coordinates.
Yeah, I can't get those straight.
How many people can?
I just asked
Think
that
you're in the
guy
normal.
or Tanya. I'm like, hey, which one's BZ?
Yeah, I at least like that because BN and BZ are basically equivalent in this.
Okay.
There's not much of a difference from Solar Orbiter to ours as to the actual coordinates themselves.
Yeah.
But then, T and N are or T and R are completely reversed in sign.
Because isn't it because it moves, the satellite moves, so they have to like.
It's how it's defined. The R direction, the first axis is defined as from the spacecraft towards the sun, whereas in our GSM, it's more so a line from the sun to the Earth that's defining it.
Okay.
So it's just the opposite direction. So if we define that as positive, that means now that coordinate is negative relative to us. Same with the T. T is then to tangential, so it's I think it points west instead of east.
Okay.
Mm-hmm.
I won't remember that, but that's fine.
That's okay. Radial, tangential, and normal.
Yeah. Well, anyway, I think that's about all we have for today. Unless you guys have anything else to add, but it's fun to go over. It's fun I always learn something by, watching the experts go over things. So I appreciate it.
yeah, you got any more questions?
Thank you so
for
much.
me?
Yeah. I don't know. Do you got any more questions while she's here? Even from you guys. I mean, I don't. I think we got.
Yeah, y'all can ask me anything.
Wait, my brain's dead. I'm in the
else,
clear.
what's your favorite color? And I'll say purple.
Purple's a good color.
It is. I like purple.
I do like the Christmas background a lot. I think it's
Thank you.
great.
Yeah, it's holidays in here.
Yeah.
Very nice holidays.
Lots of decorations.
It's very
Yes.
festive stream.
We have gone a little overboard, but it's fine.
That's okay.
Cats
Can
are
you go
happy
overboard
about
for
it.
Christmas? I don't think you can.
The kitten has
Yeah.
climbed this tree multiple times.
I believe it.
Yeah.
I yell at him
Cats
and
and
say,
trees.
"You're not an ornament. Please get off the tree."
That's what cats do best.
Yes. Yeah. Yeah. And it's a fake tree, so he's learned to climb the post from the middle underneath.
right, yeah.
So he
Oh,
just goes
God.
straight up.
Oh,
But we can do it even more efficiently.
Yeah. Too smart.
That's great. Well, thank you. And thank you for all you do, because I know how difficult it can be at times. So,
Yes.
and it can be stressful. And I'm sure being a forecaster, it's always that frustrating thing to like knowing that this isn't going to be a great forecast, but you got to do it anyway.
Yeah. Yeah, and it's hard to write out without it sounding unprofessional.
Right. Yeah.
It's hard to say, like, hey, don't listen to this, it's crap. Like, you can't say that.
Right.
Here's my forecast, and this is why it sucks.
Yeah,
right.
That in and of itself
like,
is an art.
You can't write that in donkey.
Like, this sucks.
This is bad feed.
Yeah.
Don't listen to this donkey. It got bad food.
Yeah, we got nothing great to work with here, so.
Yeah.
So anyway, but it was fine, so you did everybody the best they could with it. And things still happened, but it just wasn't what it could have been, but that's okay. There's more. There's always more.
Yeah. I'll still never forget. There was one flare early on in my career that was like, I think it was an X-class flare in the southern hemisphere on the sun, and it was closer to quiet time. I want to think it was like 2021 or something like that. And everybody was like, oh yeah, Earth-directed CME, this is going to happen. And then it never arrived, and no one talked about it again. Everyone just was like...
Was that in 2021? Or was it earlier than that? Yeah, because,
I think it was 2021. It was like an X-class flare on the southern part of the disk. And it was like, yeah, this is going to hit. It's going to be great. And then it never came, and we all were just like...
I remember this very well because it was around Halloween. And everybody was excited.
Everyone was
about
like,
it.
Halloween storm 2021.
It's not, and people all went out to look for Aurora.
Yeah,
nothing
and we all
happened.
were like,
yeah.
We're not talking about that, right?
Yeah,
no one saw that, right?
Forget it never happened. Forget, like...
No.
But
I still don't know what happened with that. Like, I feel like we're all just like, the sun duped us. I don't know.
It does what it wants.
So
yeah, it was yeah. And it always well, maybe it's just the not Murphy's Law, but like, because people get excited over the big stuff, so it seems like it just gets traction, and then you have to roll with it, and it's like even though because I'm like, it seems like these big ones always let us down.
Yeah,
but it could just be because.
I mean, May did okay.
Yeah, May did okay.
Pretty well.
Yeah.
Well, now everything is compared to May. Every time sun is tossing us a few CMEs, even if it's like slightly glancing low, there are several in the row. There's going to be somebody who's going to say, "Oh, it's going to be like May storm."
Right.
Yeah.
Well, I think part of the issue with that is that this is the first solar maximum where we've had social media like we have right now.
Yes, that is very
and
true.
So
absolutely,
it's navigating that landscape of no one can remember seeing anything like this before, but it's also like they probably never knew that it was going on. But now that we all have social media, it's getting wide like attention and everything, and then you get a little bit more of that. And so like I remember when I went up to college, I was in northern Vermont for college, and they were like, oh, I remember in like 2015 2016 or something seeing the aurora, and I was like, what, you can see it from here? No way.
Right.
And then like I remember someone being like, oh, like it was really bright in the trees, like someone who had been at the college like as in admissions for a really long time, and they had seen it in the previous solar cycle, and I was like, that's so cool. And they're like, it was so pretty. And I was like, you ever seen them? And they're like, no.
Yeah, like, nope.
Bringing up my perspective in that, being through all of cycle 24 as well. So I'd say social media, there was still like Solar Ham was still around. Space Weather Live was kind of still newish, but it was still going. Social media had been taking off quite a bit, but cycle 24 just offered nothing.
Nothing,
really didn't.
2017 in September, I think, is the only event I remember that has any sort of significance whatsoever.
Yeah.
And that was in the down phase.
24 was pretty quiet. And that's why
it was a very boring cycle.
That's why I find it.
But it was
ironic.
my first cycle, so I didn't know it was boring.
Yeah, that's true.
Yeah. And for our team, we're so young, and so there's a lot of people that are like, "Oh my god, that's so exciting" and stuff. And I was like,
oh, really? What about 23?
Yeah. This is a really tame solar cycle in comparison to what we've seen before, but it's okay because I'm right there with you, and I find this exciting.
Yeah,
still definitely exciting.
Yeah, when you talk to like Tamitha and to the one,
right?
Because she was in going through school with cycle 23 and like
Right.
these bigger ones, and then
Yeah.
so they're excited now because this one's actually waking
Doing
up a little bit.
something.
Yeah, it's doing
Yeah.
something.
Yeah. Yeah.
She's like, I got so worried. She's like, I was even wondering if we're going to see coronal holes that got 800 kilometers a second again.
Yeah. Yeah.
So at least we're getting that again.
Yeah.
Ooh.
Thankfully. Seeing
Okay, so
something.
I'm gonna share this
Yeah,
real quick
okay.
again because I finally have some actual. I
Did
can't
it
play
finally
it so that
load?
it is smooth, but the actual detail behind the actual filament
Oh
launch.
yeah, look at that.
That's crispy.
Mm-hmm.
It's nice.
Ooh.
I just love how it fans out like that. So
I love
cool.
that it
Yeah.
primarily goes through. So like you see it leave the chromosphere, and then it's mostly the bits in blue there, just
Mhm.
being the corona. So you get to see how the height differences.
Yeah.
Yeah.
Oh, yeah, that was a really good one. I'm gonna save this video, that's for sure.
It's
Whatever
always
it
good
looks
when you
like.
get the things to save.
Oh, I have a whole library of stuff now from this. Just I'll see some cool stuff and be like, all right, I got all this done. I've got it looked at. I have nothing else to do with it. Just gonna save it. I sometimes go back and look at the library, but it's been a while.
Hey, it's all good.
Do you have the really nice Lim X class flare from March of this year? Like the tail end of March?
No, I don't remember that event, if I'm
Oh,
being
now you have
quite
to go
honest.
look it up.
Hold
Yeah.
on. Hold on. I have a layout for it because it's
Oh.
so pretty.
All right,
Hold on.
take the wheel.
You gotta see it. Oh, that's the wrong thing. That's the measurement tool. So this guy, oh God, this is my favorite. I use this for outreach events, and it's my favorite event.
Oh yeah. Okay. Yes.
Oh.
Yeah.
Oh, that's
Pretty.
right.
Mhm.
It's such a pretty event. This is my
Okay.
favorite of, because it just keeps going and going and going. It's like,
That was March
man,
of this year.
I loved that.
Yeah.
Yeah, March 28th.
Let's see.
And then
Yeah,
like the resulting CME was also just like, this was just stunning.
I believe this is the one I'm thinking of. I use this one as an example for a CME core. Yeah, that's
because you
it.
could really see it.
You can see the whole structure from the side.
Yeah.
That's the good thing about the limb eruptions is that you can see things pretty good. But-
Yeah. It's one of my faves because it's just like,
Yeah, that's really cool.
Stunning. Stunning. And even in stereo, it was good.
Let's see.
Really nice in stereo.
March 28th.
You can see the shock really well in stereo. So
Yeah.
Wow.
it's just
Monster.
a pretty CME. Yeah, this is my whole event for it.
That's cool.
Yeah. Because it gave us particles.
That it did.
It was a pretty event. It's still like, this is just so good. Anyways.
Anyway, thank you. Well, that, I suppose I'll end the live part of it. But so thanks everybody for being here, or people watching later. Hopefully you get something out of this. You know, it's why we need to be careful with these forecasts, and of course don't shoot the messengers. You know, please don't.
That part's important.
They work really hard.
We don't like
And,
getting shot.
So, and I still think they do a phenomenal job given the lack of data that we have to work with. So,
Yep.
Thank you. So with that, I will end it on the YouTubes, and then I will give you guys your time back. So we'll see what we do next week.
Well, we'll talk
Oh, yeah.
about it.
We'll talk about it. We'll come up with something. So anyway, you all have a good night now, and we'll see you next
Bye.
week.